Oh my god, finally. Oh my god. Okay. That took hecking forever. Wait, sorry for the technical difficulties. Um, OBS was just having a fit, I think. I don't really know actually. But we are streaming development because I haven't done that in a while and I really enjoy it and I really enjoy sharing it with you all. So that's what we're gonna do today. I should probably make this a bit larger on low resolution in case that's the case. How is everyone doing today? What's up? We're rendering four-dimensional fractals in a 3D plane. I can't write a 4D thing. So basically, right, I was reading this blog series. I should have the blog series up, shouldn't I? Really should. Find it. Blog. This one. If you want the epic code stuff, go to this link. Ray marching, obviously, yes. This is done with ray marching. So basically, I was reading this, and it explains really well how you can generate things. Hello, Delota Slime Time. Welcome to the stream. This is going to be a bit of a technical stream. I'll show you what I have so far. It's just rendering a sphere. Oh, and with visual glitches, because it wouldn't be a Suncat stream with visual glitches, of course. We can make them more insane and less insane. Right. So, I was looking at this blog series here, and in one of the parts, I forget where, 40, no. Okay. In one of the parts, it says that creating a, so the Mandelbrot set is made, the Mandelbrot set is this fractal that we are probably all familiar with. Picture of it. Here is the Mandelbrot set. This thing. So, the special thing about it is that it's made out of this really simple formula that uses the properties of complex numbers. I'm not going to explain. They're cool. Learn about them in math if you want to know about them. To generate this really cool pattern. And the theory is, right, why aren't there fractals in more dimensions? So, the problem is, go to the third dimension, there is no way to do that, to make a 3D number system, so A plus BI plus CJ, I guess, without guessing something. So there's no true 3D fractals. It's only possible to make a 1D, 2D, 4D, and 8D number system. At least according to this blog post series thing here, which is really well written, so I totally recommend reading it. I posted the link in chat. Probably put it in the stream description, but I think it's too late. So yeah, they talk about that. My idea was, why don't we just ray march it in 4 dimensions, right? We change this 3 to a 4, and the math works out pretty much the same. And then we only render like one, like we set the z position, sorry, the 4D axis position to some arbitrary value, or maybe we can make it time. I'll use quaternions. No. So the idea is to do the math with a vec4 instead of a vec3, so we still have basically, the idea of ray marching, for those unfamiliar, is you have a start position and a direction for each ray, and then the ray marches forward at least the... So, oh my god, I need visuals to explain this. I think part 1 has a... Yes, this. Okay, so basically, can you see my mouse, or did I disable the mouse? Hopefully I didn't. The first point here, we get the distance from this point to whatever shape we're trying to show, and then we march the ray forward in whatever direction, that distance. And then we keep doing that until the distance gets really small, which means we hit the shape. So the idea is these formulas work the same. You can still like move in 4 dimensions, a point in 4 dimensions instead of complex numbers. Oh, is that what a 4D number system is called? I don't know anything about quaternions. But yes, the idea is to have a 4D number system. I haven't really figured out the math yet. I just kind of wanted to hop in and see what happens. Maybe first get a Mandelbrot going or something. And then, yeah, we can try to find maybe 4D fractals. And then the idea is do all the math in 4 dimensions. And then a last step, just pick a point on the 4D line axis and then render the 3D cross section of that. That's the easiest way to visualize 4 dimensions is through 3-dimensional cross sections of that 4D axis. So that's the idea. I got a sphere right now. So basically this just relies, you can render anything that has a distance function. So anything, the distance function, the only requirement for it is that it gives you the distance to the shape or less. Because if it's more, we could overstep and go like inside the shape. But as long as it's less, we will always be able to keep stepping until, I guess, we step too many times and we decide, well, we didn't hit it. Or the distance becomes so small that it means that we really just ran into it. Slowed down to a crawl. So that's the idea. Anything that has that can work. So for example, I did it with a sphere, which has a really simple distance function, since it's just origin, the distance from the origin to the position, and then you subtract the radius. So here maybe, I don't have a time thing. Let's add time here. That should be simple. We can make the fractals like evolve over time. So let's do uniform long. Have longs? Yes, we do. Time. Then in the code, so I pretty much lifted this code out of Minecraft 4K, my old remarching project where we remarched Minecraft, which I worked on with Jupahe. That was a really cool project. So yeah, most of this code is from there. I'm not really that familiar with it anymore. We'll figure it out. Fine. Right, so time. We have this current time thing, so we can just take frame time. We can do compute shader dot set float. So what does this do? This copies data from the CPU to the GPU. So this code here, this is C++, it's running on the CPU, and this code here is GLSL, which is a programming language that runs on the GPU, part of the computer that does graphics. So here we can go time, then do frame time. So now we're copying frame time, which is calculated on the CPU, and copying it to the GPU as a variable time here. Now we'll do your radius plus times time over 100. No, I think it's in milliseconds. So let's make it take 10 seconds to grow very large. There we go. Yell at me for it being a... Oh well, we don't need a log. We can just use float. Sure, we do. Oh, I already did float. I assumed it was a float. Minecraft 4K was... Yeah, it really was. So theoretically, the sphere should grow larger. Yes. As you can see, it grows larger with time. I'm going to disable the artifacts. And eventually we're going to be inside of it, so fun. Yep, that's just black. The distance is always 0 or negative to 0. Doesn't really make sense. Okay, sweet. So it is fractal time. Let's add. So theoretically, all we need to do is replace the distance estimator. We need to do 0.0. For that, no, I think division automatically makes it a float. But yeah, I could do point or 0.0 or .f or whatever. That way it knows. Okay. So let me close this, and I already have a thing that we can lift the Mandelbrot formula from. So I haven't tested it out. We're going to have a lot of issues with it, which is what makes it fun. So let's do that. This is great. Here it is. Let's copy that. Let's replace these defines with like things related to the fractal, inputs that it needs. Default 6.0, minimum 1, maximum 16. You know what? Let's just do that. I'm going to copy this here. Let's just make it the default. That space hurts. Here we go, default 8. So what we're going to do is we're going to hashtag define num iterations as 8. Hashtag define. This is the quick and dirty way to do it. Exponent as 6. Oh, it should be 6.0. So that it knows it's a float, as Dupahe said. Okay, undefined variable p, that should be. Then, oh god. Let's just return b. What could possibly go wrong? B. Oh, right, color. So check. Oh. How does that return a distance? Code, yes, code. Hey, we got to 1 like. Heck yeah. Why is this returning a color and supposed to return a distance? Okay, let's return this. Definitely, this is a great idea. I think it's possible to give uniform. Huh. I've never explored that. Does this work? Oh, neat. Good to know. Ooh, they added code fold. That's new. I love this extension because it's still being like actively developed, and you just have like nice features, like the GLSL code syntax highlighting thing. My funny words, magic man. Yes. So, is this gonna do anything? It crashed. We saw 1 frame of it. What the heck? What was that? Okay. So I think we have an issue where it's looping infinitely here. As travel dist greater than render dist, it might be going negative or something. So what I'm going to do is I'm going to do int count equals 0, and we're just going to count how many steps we've taken, if it's like greater than max steps or whatever. Here, count plus plus. Start it at 1, then exit here. That's dumb. No. Wait, is it? It is. Start at 0, exit at the end. If count is greater than, say, 20 for now, return false. See if that works. Get it? That's a sphere. Maybe we need more steps. 100. Fine, as long as it's not infinite. Yeah, there we go. Heck yeah. Okay, let's get closer to it. I think I broke the controls. But we can just, for now, like, just teleport ourselves, like change the spawn position, like 1 unit away, maybe. Oh, this looks cool. Okay, let's try to get lighting in. I feel like I should be more than 1 unit away, actually. Let's do like 3. That changes. Yeah, okay. And then we can fix the lighting by making. Right now, all we're doing is returning the distance, but the color that we use has to be between, I think, like 0 and 1. So and the distance is in units, so it can be like 3 or 4 or 5 or whatever. I'm going to divide it by 4. That does anything. Ooh! Whoa! That looks so cool. I'm really surprised we already got this far. That is so cool. Wow, 7 minutes in, really. I gotta send a screenshot to a friend. I was working on this before with Dad for my Discord server. Heck yeah. Okay, well, I expected to run into a lot more problems. I mean, we're gonna run into problems when actually making our own formulas and stuff, because I stole this from the... But the fact it was so painless to get a fractal going is insane to me. So, hype. Poggers, yes. PogChamp time. Okay. What are we doing next is the question. Right, we need to implement walking around so that we can fly around and look at it. Because that would be helpful. I want to observe our beautiful fractal from different angles, not just looking around. So, I got this code. I wrote it so long ago. I know it's decent code. We should change that. Fractal 40. No, gotta keep the 4 from Minecraft 4K. And let's change. Oh, we need to lines. Extra resolution, world height, world size. I don't do Minecraft 4K. We don't need classic. Actually, completely get rid of anything that talks about classic. This should be initializing, not game, right? Because this might be submitted as academic work, just as a hint. So finish initializing. Oh, running the game. That's where I saw game. Running graphics device. Running the fractalizing. There we go. This is the new word that we're using now. Okay. I remember copying that spelling from Bill Vort's History of the Entire World, I guess. Talks about how hot the world was, and I was like, yes, it's at about 1 jillion degrees. I thought that was a neat word. I stole it. Okay, so somewhere along here, render. Yes, that's a better idea. Fractalizing the renderer. Right, so controller. Here we have key down WSDA. This is the worst order. Why did I do this? This hurts. WASD. There we go. WASD. Why does that one not have a... Why is this code so inconsistent? So we just need to check controller.forward. Let's do that. Run. Sure. Right here, we can do physics with quotation marks around it, because it's not really physics, it's just moving a point. We can say if controller, control 87. What does that mean? What if? No, we do camera pause plus equals controller.forward times, and then we need the forward vector, which we need to calculate later. And then we also need to do controller.right times camera right, and then we do this controller.jump. We should rename to up because it's not a game. Don't look at me. It's not a game. No gaming happening here. This is academic work. definitely yes. This should be camera up. Okay, and now I need to remember vector map. So we have a camera yaw and camera pitch. Camera yaw, camera pitch. Oh, it's in radians actually. That's good to know. Right, so of course the first step to this is Googling get vectors Wait, no, I wrote a game engine a while ago. It has this math and just steal it from myself. My other account. Awkward. Doing it on my other monitor. Real quick. Steal the camera. Camera.cp. Have update camera vectors. Okay, there it is. So I can just steal this function. There we go. And I've got the function. So paste it somewhere. Not worry about code quality for now. That'll definitely. So camera front. Let's do camera right and camera up. That normalize the vectors because we're like this closer to 0, or you look down. Oh, nice. Calculate the. So, oh no, util. Well, util have this one. And this is camera yaw and camera pitch. Camera front, camera right, camera front. World up. Okay, so all these are going to be global vectors. That here. GLM vec3. I really feel like I should put this in a struct of camera, but whatever. Let's keep the bad code going. Camera front, camera right, and camera up. So nice to be coding again. A while since I'm. All right. And we also need world up. Let's define that real quick. That's just the laziest way possible. World up equals GLM vec3. So this is the vector that just points up in our world. So 0, 1, 0. Y is up in our case. And that should give us all the vectors we need. Oh, right, camera front. Oh no. Oh, bool times vector. You know what I think of that? I disagree. What? GLM vec3. Oh no. Operator plus equals. This is terrible. This is a bad idea. Hello, Darwin stream. Yes, heck yeah, we're live. We're live coding again, not just gaming, because we're a programming channel sometimes as well. We're making 3D fractals. We got a single fractal to render. It was so cool. And now we're messing with the camera, so we're probably not going to see a fractal in the next while. I'm going to mess up all the math. So operator plus equals GLM vec3. Left and bool right. That should be a reference, a constant. This one, const bool reference. So what we're doing right now is we're doing something in C++ called operator overloading. It means that we're creating an operation of, oh, it should be times. And we're creating an operation of timesing a vector 3D vector, and a bool, the boolean, like true or false. Thank you, Kosa, for the input. I really appreciate it. Is it time to bad the shader? No, actually, we batted the shader before. Now we're messing with the camera math. That's fun. Yes, so this should just be cool. How does that work actually? Oh, we'll just say if right return left, else return 0. Right, because if the bool is 0, that means every single component of that vector is going to become 0, so we can just return 0. And then if it's true, that means we're multiplying everything by 1. So just return itself. So there we go. Why is it not happy? Oh, because it's backwards. We also need it backwards. That's great. Do that, but backwards. Const bool left, const gln x3 right. How possible is orthography view? That should just be changing the math here. The one that we stole from Notch, who wrote it like 2010 for Minecraft 4K. This is like the only piece of code that has survived since the original project. Because this project was originally like a 4 kilobyte build of Minecraft that Notch made for some game jam. And I just stole it, and with Jupahe and later with Kosa for a tab on Discord, we basically like improved it a lot and reverse engineered it. And this was the only code that survived. Notch wrote a Brave Marcher for that game using a GPU rendering library like he did for normal Minecraft. Took too much space. Instead, he wrote his entire rendering engine, which is insane to me. But yeah, I think we just have to change this math, which I have no idea how it works. So how about you do that while I do this instead? That sounds fair. Right times left. There we go. That should work. And now we have. Okay, now the cameras work. All we need to do update camera vector here after in the mouse callback. So this is when. Actually, you know what? It wouldn't be too expensive to just update it every frame. That will save us some bugs later on. Where's the frame code? This is the problem with writing terrible code. It's that this happens. Update camera vectors. Here we go. Sweet. Fine. I wonder if no, not mess with that yet. So is this gonna let us move around? Fractal. There's oh. Okay. Well, we moved around. That was not the right direction. But hey, look, we have a cool fractal. Figure out how to go to it. Lost. Okay, so first of all, we really need to slow ourselves down. So let's divide all this by a lot. So plus equals, put that in parentheses. That. Let's just divide it by like 10 at least. And then see if we can figure out how it's moving. Fractal. Okay, so space is just moving us backwards. So all we need to do is minus camera up. Wait, no, I think our vectors are just wrong. Yeah, no. This is supposed to be moving us up, not forward. What happened here? Why is my math always wrong? So front, get the yaw, and that becomes vector. That should be. See what happens. Let's see what front is. I just move forwards. Moving like right. Is this happening? I mean, we could just correct for it later. No. It was all going so well. Now we're messing with the map. So here, like when I'm moving this way, hey, I need your help. When I'm looking up, right now I'm looking up to see the fractal. I press W, it moves you to the side, and if I rotate, wait, it seems, is it always the same direction? Let's look this way. Turn. Yeah, forward is always the same. Is it just never updated? Let's print out that we're updating. This code, I stole it from my old project. It has working code, so that's fine. Updating camera vectors goal. \n. There we go. It should just spam this. Oh no, it spams it. That means it's not the issue. This looks cool though. This looks really cool. Oh my god. Well, right now we can just navigate forwards. Oh, no, we can't. Nope. Why are the vectors not changing? If camera yaw and camera pit weren't changing. When I look around, it doesn't change. Oh, I bet this assumes. Oh, that makes sense. This probably assumes degrees. So degrees to radians. I'll check. Deg to rad. Times, yeah, pi over 180. It was something like that. So, get that. Wait, is that a thing? I thought it would be the go. Macro is not. No. Yes, we do it in parentheses, if you will. Happy now? Okay, there we go. Then we just do times deg to rad for everything. That fixes it. Else maybe we divide by deg to rad? I don't even know anywhere. Give this work. Nope. Stop mining. Don't stop mining, but mine Bitcoin. Very profitable. Don't do it in front of me. Try dividing by it. It doesn't seem to be changing still. Really weird. Any math experts in the chat? Oh, now it's changing. Oh, heck yeah. Okay, it's still wrong, but at least we figured out how to get it to like actually update. If it's right or wrong, that we'll figure out later. But hey, at least it changes now. Maybe the world up negative. Just a theory. Non-GL code from trivial. Else from Mandelbrot 40. Yeah, finding the length is actually built into GL. So I don't think so now. Probably all we need. I want to get the camera working first. But yeah, thank you for looking into that. We need to figure out how to move properly. Lately, you've been trying to get loading JSON and unit. actually. No, you should be doing fractals because fractals are cool. You should put fractals in your JSON files. In all seriousness, though, good luck. I've had success with like just using a JSON lib and like, well, whatever it outputs, you do like the data like this. Say like my thing. I don't actually know how JSON works, but I used it successfully like that. Just have a JSON library and it outputs linked hash map. Yes. Okay, let's figure out that is this. Okay, camera pause controller.forward plus times camera front. Should be right. Let me slow it down a lot because it's a bit uncontrollably fast. Maybe 10 times slower is a bit much, but oh. Ooh, there we go. No, it's slightly right. It's oh no. Just barely correct. So these need to be negative, apparently. Let's see if that makes more of a almost right, but my yaw is like inverted. So let's gate the yaw and this is so bad. Like I feel like the math is just fundamentally broken. We're just adding it. No. Like no. I'm holding forwards. Okay, jump is backwards. Actually, no, it's like side. Oh no. Why is it sideways? This is cool though that this actually works. I want to get a closer look. Need to figure out a better rendering method. Shading it based on distance. Shade it based on like. I heard from the Marble Marcher person. I should credit them. Hold up. Who made Marble Marcher? Code Parade? Yes, Code Parade. Yes, Code Parade talked about he can get free ambient occlusion, which is like how things cast shadows on themselves with remarching, basically counting the amount of steps. So if we look at the original blog post, see how if there's an overhang, the steps are going to get smaller since we're stepping based on the distance to the object. So if there's more steps, that means there was an overhang, which means you should get a shadow. So it's kind of fake ambient occlusion, but it is ambient occlusion, sort of. Doing cameras is a pain. You would think once you've done it, you can do it again. Nope. Yep. You nailed it. That's a perfect description. Hello, Decoder. Welcome to the stream. Hope you're doing well. We're about to mention what? My brain just cleared everything. So, oh, that ambient occlusion thing I was talking about. Well, this should be easy. We just do out steps, out int steps. Made custom portal colors. Oh my god. Sounds awesome. God. Ooh, also travel dist. Start at 0. Let's reset it just in case. That's what many copies. Took 2 hours. Oh my god. Don't put so much effort into the mod. It's just a joke. Fractals in 40. Can you explain how that works? On stream, Redbrain? On stream? I'm looking at stream chat. Right. Run portal. The multiplayer ones. Oh, that's not what the multiplayer ones are. God, brain is like half not working. But we got fractals rendering, so that's cool. Okay, so out steps. Here we just say steps new thing called steps. Int steps. Start at 0. And then I guess steps. Or I don't know. 4 is not enough. That's good to know. Let's do it for 100. Oops. Whoa, that looks so cool. Oh my god. And then there's people who don't do computer science. Why do you miss out on computer science? Why do you miss out on this? Look at this cool thing that you can do. Just neat. And it fixed, I don't know how I fixed the static effects, but hold up. Let me make it full screen. So let's go Fractal 4D screen. Oh, that's not the right one. That is not. that's CMD. No. Okay. Start again. I want to explore it and. There we go. Yeah. Turn up the resolution. Oh my god. This is so cool. I love math. Okay. Oh, the controls are completely messed up. What am I even looking at? Why is it black? I'm so lost. So good. There's part of me that wants to put Suncat on a hot plate. Red glow, fair enough. I mean, we do get. Oh right, is it ambient glow? Glow occlusion? Is it ambient glow occlusion? I love how like the camera controls are just slightly messed up. To the point where it's like I'm hitting space and it's going sideways. Okay. Well. What do we do now? We need to fix the camera, but I feel like that can get frustrating after a bit. Is this low res? This feels weird. Oh, because steps integer. Right. Like interpolate between them, but we can't really do that. This is fine. This is fine so far. We can make it look pretty later. Why does it look like why does it look like coronavirus? Because that's what we're doing. This is a model of the extent. How do we have 13 likes in 7 years? Thanks for all the love. That's amazing. Okay. Oh. What is the deal? God, I want to fix the camera. We do. Rolled up change. Rolled up is a great start. Cross product between front up. That makes sense. That should make right. Camera up. You know what? I know this isn't right, but let's see what happens. I'm rolled up. 7 views. What? Nice. Oh, this kind of works actually. What? Okay. Thought it would mess up the camera. Oh right, no, because the camera uses its own math. The controller's still messed up. I'm holding W, and as you can tell, it's not cooperating. Weird how it changes direction. No, it doesn't. I love the glow actually. This is 8 viewers. Let's go. Okay. Well, now remove this. Uh, look at what other people have. Our pitch yaw to direction vector. Because the camera can still be in 3D, so we don't need to make a 4D camera. I mean, we can, but like 4D can just be a separate thing, separate variable. So what does this mean? Oh, this calculates the front vector, I think. So let's do that. Oh wait, I think we already do that. Okay, so yeah, this assumes that they're in degrees. So let's first remove that. Remove every instance of GLM rating. We have the pitch and yaw gradients already. So that is a fractal the shape that when you zoom in it stays the same or something like that. So basically, it's a camera that has infinite. Why don't use the camera up and right vector? Yeah, that's what I do, but I don't have them calculated correctly. That's the issue. Decoder, a fractal is basically, it's a shape here. If I go in paint.net to effects, render, fractal. Basically, it's a shape with infinite detail. It has a limited area, but an infinite perimeter. And it looks like this. Calculate the front vector in it. Yes, I do. And that's what this function here, rotation to vector, is supposed to do. It takes in yaw and pitch. And I used it in my old game. It worked. Apparently I broke everything sometimes. Let's see what happens if I do this. Camera yaw is still negative. Still wrong. I'm holding W. Oh well. I like this glow. It's nice. I hold space to go up. I'm gonna hold D to go left, right. Yeah, okay. What's wrong with this? Any of these messages presence won't work for you? It's a bit buggy. You won't be able to debug it. Recalculate. What's wrong here? Yaw is negative. A bad flag, but that shouldn't make us like shouldn't mess with the up vector. Oh, it does because it's front. So let's not mess with yaw. It as up resolution forward. Nope, now we're backwards. Now we're just moving completely backwards. Calculate camera vectors and use and update the camera. Yep, that's what I'm doing. I feel like the yaw is like off. Or sorry, minus I. I is 180, right? Is it? I think. Just do it? No. I'm holding W. I'm going backwards. Oh, I thought it was right. Come on, don't do this to me now. Look, I look up and it goes down. I look down and it goes up. Why is the world at negative? Nope, still messed up. I'm still going backwards. Oh my god. It's always like the smallest things that just mess up and then I get stuck and then I give up on projects. But I don't want to give up on this because it's so cool. Not mess with. Oh, whatever. Let's make the 40 fractals. Wait, first let's push this code before we break it too much. You git commit, git add dot git commit dash m mandelbulb go and git push. So that way, if we mess it up now, it won't be too bad. Right, so let's start implementing 4-dimensional fractals. So the Mandelbrot set formula is just z squared plus c. There. So why does it have to complicate it? No, just, yeah, okay, here. This is nice. This is nice for non-math people. So basically, you start out with c. Z and c are equal at first. And then you square it, and then you add it. And then you plug that into here, and then you square it, and then you add it. And you plug that back in, you square it, add it, etc. And then that's how you get the new one. You keep plugging it in, and then if the value spirals off into infinity, you color it in a different color than if it stays within like 2, which means it will like forever stay in this boundary. That's the simple math behind the Mandelbrot set, and the idea would be to use quaternions, which instead of complex numbers, which are like numbers with a real part and an imaginary part, quaternions have a real, imaginary, j and k, pretty much like r, I, j, k would be the 4 bits of that number. And plug this in. However, what ray marching is based on is a distance estimator formula that calculates the distance from a point to this shape. And as you can see, the distance estimator for the Mandelbrot set does not really look like the thing for the Mandelbrot set. So that's a little bit worrying. I don't know how we're going to do it for 40. So I'm going to Google 4D distance estimator. If I can steal someone else's code. That's what we do here. 4D distance estimate. Accident. 4D fractal. Okay, so it looks like this was done, and it wasn't this thing. Julia set. Okay, so in this paper. Oh no, this paper did what I did a long time ago. Can we read it? Or is it paywalled? Access. Nope. Okay. Quaternion Julia set distance estimate. Okay, can steal this paper. Oh, I thought I was doing something original. Okay. Is there a code we can steal? Code listing. Quaternion multiple. Oh wait. What? Oh wait, this is like the set. What is it doing? Does this not have a distance estimator? What? Norm estimate. Determine the surface normal, which we'll use for lighting calculation. Combination of. Where is the intersect Q? There it is. So we need to look at that. Julia, there it is. Dist. So while 1, iterate the current array origin. We want to know this point. Oh. You'd be surprised if no one had done this. Yeah, I was hoping it was original, but that's okay. This is still really interesting. So what this guy is doing is he's taking very small array steps, and at each step, they're iterating, running the formula from the Mandelbrot set, this one, but, well, the one that applies to the Julia set, for example, and then checking whether it is in the set or not. So whether it escapes infinity or not. So there's no distance estimator already created for the 4D Julia set. So what we can do is we can take the same approach as they did, and basically just, this one I could even make it myself. I don't even have to steal the code from the internet. Just take very small steps, see whether they intersect. Although that would be a bit limiting in terms of performance and less cool as a distance estimator, because the whole point of ray marching is you march the distance, not a fixed step. But if worse comes to worse, at least we have that option. We know that that's been done before, and I guess it might be practical. I was excited to do this in a cooler way. Mandelbrot set distance estimator plus L. What does this? Mandelbrot distance. What does that mean? Why is it lagging so much? Computer, don't die. Okay. So what is this doing? I share this piece of art and code here in Shader Toy and through its public API only for educational purposes. Blah 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 blah. Okay. Shader computes the distance in a Mandelbrot set for every pixel. No space. What? Okay, so I just did calculus in math class. This has differentiation in it. So you can see this is the power rule, where you take the 2, you move it down, and then you subtract 1 from the power. So this becomes 2 times z, because the power is 1, times z prime plus 1. I don't know what this is, though. This scares me. GC log z over 2 to the power of n. Further you zoom in, the more iterations need to be done for it to not be a blob. Ah, that makes sense. That's why the fractal we looked at before, the Mandelbulb in Visual Studio, was a bit blobby. I can figure out how to get to it. First of all, if we turn up the resolution, right, it doesn't look as detailed as it maybe should, because we have less iterations. And if we look here, we can change num iterations. Well, 30, as it says here, max 30. And now it should be more detailed. Is it? I can't tell. It looks about the same to me. Maybe it's the same. Okay. Right, so I guess I need to read this. Oh no, there's actual math. You'd think, right? Rendering a math-related topic with like complicated 4D shapes and stuff would not require math, but as the name suggests and as the entire topic suggests, yes, this has math in it. I might do this off stream because it's a bit less interesting to watch, I guess, watching me figure out math. Unless you want to watch it, let me know on Discord. But I'm gonna have to end the stream because it's a bit late and I need to get some sleep. so that we can continue working on this tomorrow. So yeah, thank you all for watching. I hope you have a great time continuing on with your day or night if you're in Europe, or very early morning if you're in Asia. I'm sorry, Asia people. This is the best time for me to stream. And yeah, if you want to talk to me, I'm on Discord. You can join my Discord server from my YouTube homepage. And yeah, that's it.